All right, guys, so this is our last lesson for matrices, last lesson, and it's actually very similar to what we did yesterday. Yesterday, we spent the first micro lecture doing a skill, learning a new skill, and that was finding the determinant. Okay, and we used that skill and our favorite dead mathematician Gabriel Cramer's rule to solve a system. That was yesterday. So again, we did a skill, and then we learned how to solve a system a new way. Today's the same process. We're going to learn a new skill, and then we're going to use that skill to solve a system another way. Okay? So again, it's going to build on itself. Now, the reason I put these problems in the rewind, I think you're all familiar with number 2, why I would do that. We did it yesterday. This is something we did last week, but do you think you'll need that again today? Yes. Okay, so you'll need both of these things today. All right, so let's start by talking about how to find the inverse of a matrix. This is the new skill today. Again, you've never done this. Your brain has never seen this. All right, and you're going to learn how to do it. That's cool, right? That's exciting. All right, so just take 10 seconds and just read this box right here. I have the same. Oh, I don't have the same one, but I have the same case. Oh, mine's blue. Now, there's one thing I want to point out that you should already recognize. DET. That means determinant. So that step right there, we already know how to do. You guys already learned that yesterday. This is a little tricky, but again, this is new. Your brain will get it. Look at this matrix, and then look how they wrote this matrix. So see if you can find out what they did. What did they do with A and D? They switched places. Do you see how they switched places? Right? A and D switch places. What about B and C? What did they do to B and C? Did they switch places? No. That actually doesn't mean make them negative. It means make them the opposite. So if they are negative, they'll become positive. If they're positive, they'll become negative. So make them the opposite, okay? So all of that together, I'm going to explain what we do after that. That's going to help us find the inverse. All right, so let's do an example together. All right, the first thing you want to do, and I'm just going to label this as matrix A. All right, A, because it's the first one. And I want to find the inverse. The first thing I do here is I want to find the determinant of matrix A. I'm going to call on somebody to tell me how to find the determinant of this matrix. And that someone is Adon. Can you tell me how to find the determinant for this matrix? -2 times. Very good. What operation do we use with determinants? Adon. Minus. You can use your words. Subtraction. And then what is the other thing I multiply? 3 and 2. Excellent. Take 10 seconds, everybody. Find this determinant. And it is, Miranda, it is 2. Salute. It is 2. All right, again, is that new? No, that's not new. That's the same. All right, which is exciting. You already know how to do it. That's great. Now, the new process is about to happen right now. I want you to write A to the negative first power. This notation is important because it tells you what we're about to do is going to be to find the inverse of matrix A. So anytime you see a matrix letter raised to a negative first power, that's telling you they're going to find the inverse of that matrix. All right? That's what that notation means. Everybody good? Okay, that's new. Equals. I want you to write 1 over, and what did Adon just find for the determinants? 2. So whatever you get, you put there. So if we would have found 4, it'd be 1 over 4. If it's -8, it's 1 over -8. Okay, that's what you put there. Times. Here's where it's a little tricky. So again, my -2 and -4, what's going to happen with those guys? Very good. They're going to switch places. They're going to switch places. What about for this 3 and 2? What's going to happen to them? Are they going to switch places? No, they're going to switch signs. They're both positive, so they're going to become both negative. Again, that's going to take a little time, right? We're going to do multiple examples. You'll get to do some at your boards, so it will come to you. All right? Yes?
Wait, I forgot. What did you do on the 1 over?
So the 1 over part is always going to be 1 over. Whatever you get here, you put that in the denominator.
So if one is negative but the other one's positive, the one that's negative is going to be.
You got it. Exactly. So like if it was negative 3 and 2, it'd be 3, negative 2. They switch. Signs. Just signs. Okay. Now, here's what you can do to find your answer. So here is your inverse matrix. Take all 4 of these numbers and multiply them by 1/2. But I'm not going to do that because multiplying by 1/2 is the same as doing what? Dividing by 2. So I'm going to divide all these numbers by 2. All right? Divide every single number by 2. That is our inverse. All right? So we have negative 2, negative 1, negative 3/2, and negative 1. Again, fractions or decimals. Fractions or decimals. I do not care. Whichever one you prefer. And if you prefer neither, pick one. Any questions so far? Guys, that's the process. Yes, Janice. That's the process. That's it. What is in black is the inverse of matrix A.
Oh, so you didn't. Okay, well, you didn't do the 1/2 times.
I did, but instead of doing negative 4 times 1/2, which is negative 2, I did negative 4 divided by 2, which is negative 2. It's the same process. I prefer to teach students using thinking division. So like if this would have been 4, all of these numbers we divided by 4.
So it's always going to be a matrix.
Yes, it'll always be a matrix at the end. Can we try another one? All right, let's go to example 2. Ejemplo 2. First thing, we need to find what? Determinant. Now, just for funsies, watch what notation. I'm going to label this matrix B. Watch what notation I put. Ooh. Usually you think what when you see those symbols? Absolute value. But with matrices, you think determinant. Okay? Talked about that yesterday. Just want to bring that back again. Okay. Let's see. Who am I going to call on for this one, for the determinant? Who am I going to call on for this one? Kiana. Very good. So half times 12 minus 3 times 2. Take 10 seconds. Calculate it. Don't tell me. Don't tell me. Don't tell me. Luis, did you get something? You got 0. Did anybody else get 0? Yes. Okay. So let's just pause and think for a second. If I think back to what we just did with example 1. With example 1, whatever I got there, I got 2, right? So I took all these numbers and divided by 2. So with this process, I'm going to take my numbers, whatever they are, and divide by 0. And what do you know about dividing by 0? You can't do it. You cannot do it. All right, I've said this many times. I'll keep saying it. Have you guys seen The Day After Tomorrow?
Yes.
Right? It's just all those bad things happen. It's because somebody tried to divide by 0. Well, don't do it. Okay? You can't. So if this happens and you get 0, you're going to write 2 things. No inverse, because this is a singular matrix. So there's no matrix inverse for this matrix, no inverse for this guy, because 2 phrases. Sorry, Lucy. 4 words, 2 phrases. Because this matrix is singular, excuse me. All right? Single. Not single. Can't write no solution, right? You write no inverse. Singular matrix.